Hey, I'm Steve from Kiln AI. Today, we're going to show a demo of how to set up an AI project the right way, including evals, synthetic data, fine-tuning, and collaboration tools. And to do that, we're going to walk through a whole project end to end from writing the very first prompt to having an optimized system with evals and fine-tunes. And we're going to do that in a way that makes it easy to collaborate and iterate in your project. So when you have a new product change you want to make or a new model comes out, you're set up really well to iterate on your project over time. For the demo project, we're going to make a tool that converts natural language into ffmpeg commands. For those of you who don't know what ffmpeg is, it's a really powerful command line tool for editing videos and audio files. And because it's so powerful, the commands can get pretty complicated pretty fast. So having a natural language way to say, hey, can I convert this video into 720p and set it up for streaming on the web is actually really nice compared to trying to memorize all of these different parameters. And this project was inspired by a cool project I saw on GitHub. We'll use this as a starting place, and then we're going to iterate and see if we can improve the quality and performance of this system. Let's get started. Okay, the first thing we need to do is set up a task. Task basically describes what the project does. So we're going to set up a name and prompt. There we go. I've added a name for our task and a description basically saying that we are a tool that converts natural language and ffmpeg commands, and have an example of basically asking you to convert a file for use in a browser, and a nice detailed example of the kind of output we want to see. We'll just set up the input schema as plain text since it's natural language, and an output schema as plain text as well, and create our task. And now we can run it. It's not too much to it. We can pick a model like GPT-4.1 and ask it for an ffmpeg command. And GPT-4.1 has come up with a result in a similar format using kind of just the single shot prompting we gave it. And I'm going to assume that's correct. And we can just try a bunch of other models really quickly. Let's try Sonnet 4. Looks good. Let's try Opus. And let's try some smaller open models like Qwen 3. And Qwen's produced a result too. Now, you can use this UI to spot check a bunch of different models and tune your prompt and try to find a great way, but that gets hard quickly. There's thousands of possible inputs and dozens upon dozens of options in ffmpeg, so we want to do something a bit more robust and repeatable. So we're going to make an eval. Let's hop over to evals. Select Create a New Evaluator. We're going to create an issue eval just focused on correctness. All right, I've typed up a quick evaluator description. Basically say for focus on correctness, we want to make sure it doesn't make mistakes, and give an example of a mistake where it hallucinated a parameter that doesn't actually exist in ffmpeg. So we'll create that issue. It's automatically pre-filled the evaluator template with a pass-fail requirement for correctness, given the information we just gave it, and created two new data set tags, eval correctness and eval golden correctness, that we'll use for the data for this actual eval. We can create that evaluator. And the next step is to start adding data to those two data sets. Luckily, Kiln can help with that. We use something called synthetic data generation. So I'll click eval data, select synthetic data generation, and now it's set up to generate data for exactly this use case. It knows we're generating data for an evaluation, it knows we use the issue eval template, and it's going to assign 80% of the generated data into our eval and 20% into the golden set for this eval, which we'll talk about in a few minutes. There's multiple ways to add data to your eval. You go online and get hundreds of examples of ffmpeg commands and import them manually in a spreadsheet, but we're going to use a large model to generate synthetic data for our eval instead. So the first step of that is adding topics. The reason we want topics, if you ask a large model to produce an example 100 times, it's going to most likely produce 100 very similar examples. By using a topic tree, we can actually force it to generate really wide variety of examples. So we'll ask our synthetic data generation system to add topics. We'll select a high quality model like Sonnet 4 for the actual generation. And it's actually going to go read the issue that we're trying to solve, which is correctness, understand the goal is topic gen, and generate what it thinks are appropriate synthetic data topics for an evaluator. And it's come up with a bunch of different examples of failure modes that can happen when generating ffmpeg commands. So these are just the high-level topics, but we can go add model inputs, basically the input to the command for each of these. So we use Sonnet to generate those as well. And in just a few seconds, it's generated hundreds of potential inputs into our system. These are the user messages that would go into our ffmpeg converter. And it's done actually a really nice job. And now I'm going to ask it to actually go through and run the full process, saving outputs for all of those. All right, and that's done generating. We can pop over to the Dataset tab. You can see the synthetic data that was generated just now, and that it was properly assigned into our eval. And a random 20% has been assigned into our golden correctness dataset, which we're going to use in a minute to make sure our LLM-as-judge evals actually work. Now we can return to our eval and pick up where we left off. And as you can see, we moved on to the next step. In this case, human ratings, followed by finding the best judge. Now, I'm not going to walk through these in details in this video, but if you're interested, check out our evals video in our docs, which does walk through these. But at a high level, first step is to rate some of these data sets with a human to make sure we know what correct and incorrect look like. And then we're going to compare a few different LLM-as-judge eval systems and make sure that they match our human preferences. Basically, that they can do the right thing at scale. And that gives us faith that the LLM-as-judge systems are working just like a human judge would. So let's do that now. All right, and through some trial and error, I found an LLM-as-judge that was actually really effective at judging the output of these. The trick was using GPT-4 Mini, but I actually included the man page of ffmpeg, allowing it to suss out errors better. So that worked quite well. Now we can go on to the fun part, comparing run methods. So this allows us to basically find what's the best way of running this task. So we'll add a quick one. We'll use a high quality model like Sonnet. And with the basic prompt we already created, maybe we'll try adding another run method for a cheaper open source model like Qwen. We'll add a Qwen thinking model as well for comparison. Some models from OpenAI. We'll add Phi, since that's what the open source project we're emulating used. We can also pop over the prompts tab and add a custom prompt, because we can compare not only different models here, but different prompts and how they work. We'll try the prompt from this open source project, which is a big multi-shot prompt with a whole bunch of different examples. And add a few run methods using that prompt. And now we've got a whole set of experiments queued up. And this is going to run, use our evals, and our judge is going to check which of these actually perform best on this task we defined, which is correctness. So we can kick that off. All right, the evals are done running. We have our results. Some really interesting things here. So we can see the score, the pass rate of each of the different model prompt pairs over here on the right. And some surprising and not surprising things in the results. GPT-4.1 is our winner. GPT-4.1 Mini, despite being a lot cheaper, does really well, actually outperforming Claude Sonnet, which is much more expensive and a larger model, so that's interesting. We see pretty good performance from some of the open source models, like Qwen 8 Thinking is actually quite good given its size and cost. Qwen 3.32, pretty good too. And then we see some really awful performance down here. Things like Phi, only being right less than 30% of the time. We've interesting insights on the prompt. So that prompt actually makes Sonnet a lot worse, the one we pulled from the open source project, whereas that prompt can help Phi, which is what they used it with. So interesting insights, helps us actually very quickly try a whole bunch of different methods. Let's go over to the compare screen inside of Evals and select a few models. All right, I've selected a bunch of the higher end, more expensive paid models, and you can see it's pretty useful to help you compare. We can see the difference in correctness between them. So comparing GPT-4.1 to 4.1 Mini, it's only a 1% drop in correctness for an 81% reduction in cost. That's pretty appealing. And 4.1 Nano's 5% worse, which is pretty bad, but at 95% reduction in cost. So depending on your balance, you might choose one of those two models. Whereas something like Sonnet is negative 5% correctness at plus 98% cost. So there's really no reason to choose that over the other ones here. And we compare the open models too. So you can see Qwen 3.32 billion, the largest and newest model, does the best, but Qwen 8 non-thinking, pretty good, but probably not worth the cost benefit at dropping the quality 16%. And older models like 5 really just don't stand up for this task. So good insights in just a few clicks. And after you're done, you can actually pick a default to use in your project. I'm going to pick 4.1 Mini because it's a fraction of the cost of 4.1, and it's almost as good. And now returning to the eval, we can see our eval is complete. Or is it? Do you ever really finish a software project or a product? Usually something new comes along at some point. You want to change it, you want to evolve it, you want to make it better. You see a user with an issue where a PM shows up in the request. By setting up an eval, you're actually set up really well to try new tech or new ideas as they come out. Maybe you want to try a new model. Kimi K2 that came out the other day, so we can try adding that and run our eval. All right, and the results aren't that great. There's a drop in quality with an increase of price. So that's probably not what we'll do. But someone on the team's come up with a new prompt idea, so let's try that. We can add a new run method and select the new prompt. And let's run that. All right, that one's cheaper because the prompt's shorter, but there's a drop in quality, so we probably don't want to select it. And now let's try another idea just for fun. Let's try running against a local model running on a llama. All right, that melted my GPU, but it's done. The results aren't anything stellar, but it did cost $0 because it ran locally and was completely private. So if you were trying to build a private system, you could use this to iterate and try to find the best prompt in a local model pair that works for you. Again, the really cool thing here is that evals have made it possible to really iterate quickly, trying different prompts and different models to find the best way to run your task. Now let's try something really cool. We can pop over to the fine-tuning tab. We can build custom fine-tuned models for this use case, and then use our eval to verify it actually boosts performance. Now, I'm not going to show the entire process in detail here. We've got a fine-tuning video. You can go check that out if you want to see all the steps, but let's do a quick version of fine-tuning right now. Just click Create a Fine-Tune, add fine-tuning data, and select synthetic data. And you can see the synthetic data gen UI knows that we're fine-tuning and is going to assign the data to our fine-tuning data tag. Now we'll create topics and data just like we did for evals. The neat thing here is that the synthetic data gen is aware that we're fine-tuning, so it's actually coming up with use cases that make sense to give us a breadth of topics for fine-tuning data, just like it did in synthetic data. We'll keep generating data now. And when we generate training data, we'll use GPT-4.1 because it had the highest score in our eval. And that's complete. We can return to fine-tuning and continue the process. You can pick which model to fine-tune. Let's keep Lambda 3.2, 3 billion for this first one. We'll create a fine-tuning data set using the tag we just populated, and simply click Start Fine-Tuning Job to kick off a cloud-based fine-tuning process. Back in the fine-tuning tab, I'll kick off a few more fine-tuning jobs so we have a range of models to compare. All right, this time we melted some cloud GPUs. We trained about 12 fine-tunes across a variety of base models and providers. It's always fun spinning up like $500,000 worth of hardware in the cloud, even though most of these cost less than $1 because we only need that hardware for about 5 to 20 minutes for a fine-tune. And when those fine-tunes are complete, we can click Run Fine-Tune, add a prompt, and click Run. And our fine-tuned model has responded with its answer. And back in evals, we'll kick off a new evaluation run for our new fine-tuned model. Let's look at some results. This fine-tune of Gemini Flash is really promising. It got a 16% bump over untuned Gemini Flash, being almost as good as Sonnet 4, while being 37 times cheaper. Here's another fine-tune where I saw how small we could go to see if we could make a really small 3 billion parameter model that could run locally. And yep, we've got some good boost in performance by fine-tuning here as well. This was by no means an exhaustive fine-tuning exercise. We'd probably want to try more data and different hyperparameters, but a quick experiment shows that fine-tuning shows some promise for the space. So we just showed how a good eval can help on the technical side. It can help with prompt iteration or selecting the right model and even fine-tuning. But a good eval can also help on the product side. Anyone who's worked in product before knows that products evolve over time. They have changing requirements. They have bugs that come from customers. So evals are a really good way of capturing all those things to make sure you don't regress and break things that you've already solved. Let's run through an example. Say a PM comes up to you with a use case. They've realized they can actually ask the model to delete every file on their hard drive and it will happily comply. So we want to now refuse inappropriate instructions. Let's build a new eval around that in parallel with our first eval. And we use synthetic data gen to create some eval data, just like we did the first time. All right, we've run that eval, and we can see that it really was a problem. The refuse destructive instructions prompt only has a 2% pass rate, so it would happily comply with deleting files if you asked it to. We've made a prompt change to try to fix that, clarifying that's not something we want the system to do, and lo and behold, huge 4,500% improvement. So all it took was a prompt change to fix it. But it wasn't free. There was a regression in correctness when we did that. So there might be a genuine trade-off here of adding more requirements to the prompt makes it less effective at one part than the other. Or it might just be that our eval for correctness needs some work and there's some requests for destructive edits in there. So that's something we have to go work on next. And that was just one example of a product change you might want to make. But over time, products tend to evolve, and you might accumulate a lot of these, like only re-encode when necessary, don't recommend competitors, decline off-topic requests, some technical requirements. And you can just keep adding evals to your system as time goes on to allow you to kind of manage all of that complexity. You might think accumulating a ton of small evals is a bad thing, but it's actually a really good thing. Trying to maintain one big eval that encapsulates everything you want your product to be is next to impossible. You continually have to get all the stakeholders in the room. They have to be going over spreadsheets of data in great depth. But a bunch of small evals lets individuals who care about certain things manage those on their own, and then we can find kind of at the top level where they conflict and when you have to make trade-offs. We've even got a blog post on this concept called Many Small Evals Beats One Big Eval Every Time, all about how it's easier to manage a lot of small evals than just to try to create one uber eval that encapsulates your entire product. And one of the core ideas is that big evals can kind of really hide important regressions. So while your overall product score might go up, it might be really some things went way up and some things went way down, and you want to go understand that nuance when you're shipping new prompts, new models, new fine tunes, and iterating on your product. It's kind of like software testing. You wouldn't try to write one test case for your entire app. Don't try to write one eval for everything your AI system does. A bunch of small evals really is the way to go. I mentioned collaborating with your team a few times. Kiln is designed to make collaboration really easy and powerful. Kiln projects are just files in your file system, and they're designed to be shared through tools like Git and GitHub, so everyone on your team can work on the project in parallel. You can have data scientists creating fine tunes while experts are labeling data, and PMs and QA are creating evals, all in parallel and all working together. And the project files are easy to understand. You can see the same files inside the folder structure that you see in the UI. It's easy to build extensions and hack on however you like. And one of the best parts is that Kiln is completely private. It runs on your own computer. It's not a hosted cloud service. And the files are on your local hard drive. They're only shared if you share them with somebody. We never have access to your project data or files. And this whole project that we've been working on is available as open source. It's a demo project. So if you want to pick up this exact project we've been working on, you can just download it from kiln.ai/demos, load it into Kiln, and you can see the exact project file that we've been building throughout this video. And while this video is focused on the Kiln app, there's also a Kiln Python library. It's completely open source. So if you're a coder, you can load Kiln projects and run Kiln tasks from code as well. All right, let's recap everything we saw in this video. First, we created an eval. We used synthetic data to generate an evaluator with hundreds of samples, allowing us to reuse it over and over again instead of kind of one-off spot checking, giving us a much more rigorous process for seeing how our system works. Next, we use that eval to find the best way to run our task. We could try different prompts and different models and find the most optimal way with an actual repeatable, measurable method. Next, we took that even further and tried creating some fine tunes. With synthetic data and fine-tuned results, we could see how much we could improve the system from fine tuning. After that, we looked at how we could expand our AI system, adding more and more evals in a way that allows a lot of team members to collaborate together and work on different parts of the problem that form the whole. And finally, we looked at how to collaborate with the team, adding your data to GitHub and syncing it so everyone from PM to QA to design to engineering and data science can all collaborate together on the same project over time. These are the basic building blocks that every AI project and team needs. And hopefully by watching this video, you're convinced that they're actually not that hard to get set up properly, and that they're kind of like software tests or CI. They'll take a little bit of work to set up, but they pay big time dividends in efficiency over time and really help you improve quality of your AI systems. This was a demo and we went pretty quick. If you want to do any of these steps on your own project, I suggest you check out our docs and video guides on docs.getkiln.ai. We walk through the steps in a lot more detail. We give articles and videos that kind of explain how to do all of these things. It's a really good resource, and you can download the Kiln app for free from there. If you need any help, you can reach out to us on our Discord. We're happy to help answer any questions and are looking forward to seeing what you build with Kiln. And thanks for sticking through the whole video. I hope you learned some interesting things about how to set up a good AI workflow for your team. Please check out Kiln. You can check it out on getkiln.ai. It's got over 4,000 GitHub stars, so you'll be joining a lot of happy people building cool AI products. Thanks for watching.